Moving fast where humans are more in control. First of all, humans are in the loop versus being out of the loop. It's a design choice, which at least we have made.
I believe it creates more, I would call it, both satisfaction in current jobs and net new jobs.
Have you heard of Kosmos 2, a new model for multimodal AI? Microsoft researchers have recently unveiled Kosmos 2, an advanced multimodal large language model that connects with the visual realm. And it all keeps getting better and better. In the world of AI research, the spotlight is currently on Kosmos 2, a remarkable multimodal large language model that brings a fresh perspective on information processing. But what is it good for? Clever or just trying to keep up with the competition? Let's find out. The groundbreaking design of Kosmos 2 allows it to predict text descriptions based on the location tokens of bounding boxes, a process often referred to as phrase grounding. The model exhibits excellent performance in referring expression generation, significantly outshining its rival, the SLR model, especially when it comes to zero-shot performance. The skill improvements it showcases with few-shot demonstrations further underline the detailed and effective nature of Kosmos 2. Multimodal large language models or MLLMs have shown remarkable success as a versatile interface across various tasks involving language, vision, and vision-language interactions. These models can understand and generate responses using diverse modalities such as text, images, and audio under zero-shot and few-shot conditions. In this study, we leverage the grounding capability of multimodal large language models, enabling them to establish a connection with the visual world. This grounding capability is precious in vision-language tasks, facilitating a more practical and efficient human-AI interface. The model can effectively interpret specific regions within an image using their geographical coordinates, empowering users to directly reference and identify objects or areas without requiring lengthy textual descriptions. But wait, let's not get too ahead of ourselves. Let's first find out how does Kosmos 2 work. Kosmos 2 uses VLP to learn from different types of data, like text, images, videos, or speech. It has three parts: an encoder, a decoder, and an aligner. The encoder turns data into hidden states using transformers that pay attention to both words and images. The decoder creates new data from hidden states using transformers focusing on words and images. It also makes one word or image at a time. The aligner matches data across words and images during training. It uses contrastive learning to make similar things closer and different things farther. It also uses masked language modeling to fill in the blanks in data. Key features of Kosmos 2. Large-scale multimodal pre-training. Kosmos 2 is pre-trained on a large-scale multimodal corpus of over 1.8 billion samples, covering text, images, videos, speech, captions, metadata, and web pages. This enables Kosmos 2 to learn rich and diverse representations and knowledge from various data sources. Unified Vision Language Framework. Kosmos 2 adopts the Vision Language Pre-training (VLP) framework as its backbone, integrating visual and linguistic information into a unified model. VLP allows Kosmos 2 to leverage cross-modal attention and self-attention mechanisms to enhance its representation and reasoning abilities. Multimodal fusion and generation. Kosmos 2 can fuse multiple modalities into a single representation and generate new content across modalities. For example, Kosmos 2 can generate an image from a text description or a video from a speech transcript. Kosmos 2 can also perform multimodal alignment and retrieval tasks, such as finding the most relevant image or video for a given text query. Researchers at Microsoft Research have introduced Kosmos 2, an enhanced multimodal large language model based on Kosmos 1, featuring advanced grounding capabilities. The model's grounding feature allows it to provide visual responses, specifically bounding boxes, which greatly assist in vision language tasks like understanding referring expressions. Visual responses offer higher precision and clarity, resolving coreference ambiguity more effectively than text-based responses alone. By incorporating the grounding capacity, the resulting free-form text responses of the model can connect noun phrases and referencing terms to specific areas in pictures, resulting in more accurate, informative, and comprehensive responses. To train the causal language model Kosmos 2, researchers developed a web-scale dataset comprising grounded image-text pairings. This dataset was integrated with the multimodal corpora in Kosmos 1 to leverage the grounding potential fully. The grounded image-text pairs were derived from a subset of LAION2B and COYO700M, and a pipeline was established to extract and align text spans, such as noun phrases and referencing expressions, with spatial positions bounding boxes of relevant objects or regions in the images. The geographical coordinates of the bounding boxes were converted into location tokens, which were then added after the corresponding text spans. Experimental results demonstrate that Kosmos 2 excels in grounding tasks such as phrase grounding and referring expression comprehension, as well as referring tasks like referring expression generation. Additionally, Kosmos 2 performs competitively in language and vision language tasks evaluated in Kosmos 1. However, Kosmos 2 is not an AI confined within the boundaries of referring tasks only. It also flexes its competence in vision language tasks such as picture captioning as well as visual question answering. This means it can generate text descriptions of images and answer questions pivoting around given images, even though it performs neck and neck with its precursor, Kosmos 1. In these tasks, it showcases slight improvements in areas like image captioning, albeit at a negligible cost of a minor decrease in visual question answering. And so, Kosmos 2 rises to the challenge when thrown into the arena of numerous language tasks, including close and completion tasks, Winograd-style tasks, common-sense reasoning, and much more. This system's performance parallels Kosmos 1, with improvements outweighing minute performance regressions. These results hint at the model's wide-ranging potential to enhance its skills in myriad domains. Kosmos 2 fine-tunes its abilities courtesy of a comprehensive pre-training regimen involving a multimodal corpus called Kosmos 1 and a supplementary dataset named Grid. This pairing gifts Kosmos 2 and other multimodal large language models with the ability to appreciate image regions, helping them route their text outputs to the visual landscape. This real-world grounding is a cornerstone in enhancing their downstream application effectiveness. An analysis of the model's performance across multiple facets found that Kosmos 2 outclasses its peers in many language and vision language tasks. In fact, it reigns supreme in referring to expression comprehension and phrase grounding. In a nutshell, Kosmos 2 has emerged as a major player in multimodal large language models, making significant strides in bridging the gap between language and vision. Microsoft's Kosmos 2 is the embodiment AI prototype. Maybe this is the first time you have heard about embodiment AI. Well, the name is pretty suggestive in itself. So what is embodiment AI, you might ask? Embodiment AI is a field of artificial intelligence that focuses on developing intelligent agents with a physical body that can interact meaningfully with the world. The concept is based on the idea that the physical body plays a significant role in how an agent learns and makes decisions. In other words, if AI had a body that would move, it could learn from this, respond and form answers, and interact accordingly. And if you think we have entered science fiction territory, hold your ground. AI was always supposed to become physical. According to the research, Kosmos 2 is a language model that enables new capabilities of perceiving object descriptions and grounding text to the visual world. The researchers represented refer expressions as links in Markdown, such as text span, where object descriptions are sequences of location tokens. Together with multimodal corpora, they constructed large-scale data of grounded image text pairs to train the model. In addition to integrating the existing capabilities of MLLMs in Kosmos 2, the model also integrates the grounding capability into applications. This means the language has taken steps forward into perceiving space and developing its own perception, action, and world modeling. The researchers think this way Kosmos 2 is the foundation for a physical AI. So, the bottom line is that Kosmos 2 is a remarkable achievement in artificial intelligence, and it opens up new possibilities and opportunities for multimodal learning and generation. It is a step closer to the ultimate goal of general AI, to create machines that can understand and interact with the world as humans do. What are your thoughts on this? Let us know in the comment section below. If you liked today's video, then make sure to leave us a thumbs up, and do not forget to subscribe to our channel and click on the bell icon to be always updated with the latest AI content.